Hi, I'm Ash, currently doing my research on borosilicate glass slide as a thermoluminescence dosimeter for CO-60 high dose rate brachytherapy. And what is brachytherapy? So a brachytherapy is a commonly radiotherapy treatment that used to treat cervical, prostate, breast, and skin cancer, which typically use the applications of sealed radioactive sources that are inserted within or alongside the area to be treated. What is thermoluminescence? A thermoluminescence dosimeter, or TLD, is a type of radiation dosimeter consisting of a piece of a thermoluminescent material inside a radiolucent package. Why did I choose borosilicate glass as my sample? Not only it has various thickness available in the market, and for my work I use 0.1mm, and it also relatively low cost and mechanically robust. And not only that, it's biocompatible and also impervious to water. There are two main objectives in my work. The first one, to characterize the thermoluminescent properties, which is the dose response, sensitivity, fading, linearity index, and glow curve. And all the sample were irradiated to CO-60 high dose rate brachytherapy source. The next one is to determine the optical characterization using Raman and photoluminescence spectroscopy, and these samples were irradiated using CO-60 gamma ray source. How did I do my experiment? It started with cutting the glass dimensionally using the oil diamond cutter, and then rinse in the acetone for the cleansing purposes, and then it went under the heat at 400 degrees Celsius for 1 hour under the process called annealing. So annealing process is actually to eliminate previous exposure or triboluminescent history, and just for remembrance, the samples were kept in the darkened condition pre and post irradiation. And then after 24 hours, the sample will undergo irradiation under two different modalities, as I said before, which is CO-60 brachytherapy, which is available at the University of Malaya Medical Center, and also CO-60 gamma ray source using gamma cell, which is located at the Department of Physics. So for brachytherapy irradiation, it irradiates to 0.5 to 8 gray before undergoing the readout process using thermoluminescent dosimeter reader TLD100. But while for the CO-60 gamma ray, the sample was irradiated from 2 gray to 10 gray, and then the sample was sent to the Low Dimensional Material Research Center at University of Malaya for Raman and photoluminescence spectroscopy. So, as I mentioned earlier, I will explain two types of property, which is thermoluminescent and also optical properties. So here's the result for the thermoluminescent properties. The figures illustrate the mass normalized dose response for the borosilicate glass with doses in the range of 0.5 to 8 gray. A regression coefficient of 0.9645 being obtained. The next one is a graphical summary of the thermoluminescent sensitivity of the glass carried out in this project. The difference in sensitivity at the higher dose due to low optical signal, which provide a high signal to noise ratio. The next property is fading, which takes 35 days to complete. Over the period of 35 days, the glass experienced loss of thermoluminescent signal exponentially and contribute to 55% as depicted on the figure. In seeking to make further definitive statements regarding the response of the borosilicate glass, the linearity index has been carried out using the formula as shown here. So according to the figure, it is apparent that the response of the borosilicate glass depicts linearity at the dose of 0.5 gray, while for the doses more than that, the sublinearity is observed, which typically believed to occur when the thermoluminescent material reaches saturation in electron hole trap numbers. An important physical factor in determining the stability of the given thermoluminescent material for medical application is the temperature at which the peak of the glow curve occurs. So the figure shows the stacked glow curve with background subtracted for the irradiated glass sample. In an extensive experimental procedure, the deconvolution of the thermoluminescent glow curve was carried out using an alternative method called T-max T-stop, which can be effective in identifying sub-peaks position. According to the figures, It shows the evidence of 5 staircase-like plotting corresponding to the existence of subpeaks positioned under the encompassing glow curve. And following the mentioned method, the glow curve is then deconvoluted using glow fit software with 5 subpeaks being apparent underlying the broad peak of the glow curve. Now, we're moving on to the next property, which is optical properties. These properties has been carried out using Raman and photoluminescence spectroscopy, and the sample were irradiated to cobalt-60 gamma ray with a dose ranging from 2 to 10 gray. For Raman, this method is non-destructive, contactless, and also easy, being made as the best tool to analyze the structural defects and vibrational bands in the glasses. So the figure represents the room temperature of Raman spectra. In this frequency region, the Raman spectra have been divided into 6 main bands centered near. And the next one is photoluminescence spectroscopy, which is the very sensitive analytical method and also important optical property of borosilicate glass for its application, which depends strongly on active centers surrounding host composition and their interactions. Figure shows the photoluminescence spectra plotted with 2 broad peaks. The first peak and the second peak represent the excitation photon and emission photon respectively. The energy band gap is considered to be obtained from the peak of emission photon, which is the second peak. The value of energy band gap for each peak was calculated using the equations of energy equals to the multiplications of Planck constants and speed of light over the wavelength, and the average value of energy band gap is to be 1.2 electron volt. In order to develop a precise thermoluminescence dosimeter, the borosilicate glass needs to extend its study in depth on optical characterization using cobalt-60 high-dose rate brachytherapy irradiation for the energy dispersive X-ray, phototransferred, thermoluminescent, and also X-ray diffraction analysis. Above all, the borosilicate glass can be possessed as an ideal thermoluminescence dosimetry for the applications of the high-dose rate brachytherapy treatment. And as a physicist, I hope that this finding can be beneficial to the society in the future.